Welcome to Study Loop.
For this problem, we're going to be offering an extensive view of how to solve two equations when you have two unknown variables. So really the possibilities are endless with this kind of stuff. Sometimes you're talking about food, sometimes you're talking about costs and percentages, but we see that this comes up a lot in math where we have two different equations and two unknowns, and because of that, because if as long as they're linear equations, we can find solutions, or we can show that there's no solution. So what this looks like is we have some values, maybe 3x plus 2y equals 5. So off the top of my head, something this could represent is that you have hamburgers and you have french fries. X is hamburgers, y is french fries. The hamburgers cost $3 and the french fries cost $2. I know, super unrealistic, but what you know is that after this order, you ended up getting, it ended up costing $5. Um, so then we would need another equation because we have 3x plus 2y equals 5. So we would need another function here to represent something else. So perhaps you know that x plus y. So this is just the hamburgers plus the french fries. You know that combined there's two items. Well, what that tells you is that the number of hamburgers purchased, there was one hamburger purchased and there was one french fry purchased. However, this can become much more complicated. We could increase the prices and all this kind of stuff. And these lines would shift around, but they would still have at most one point of intersection. They could have an infinite number of points of intersection if they were the same line, potentially. So that's how we do it. Now, there's a couple things we want to look out for. So when we have these two equations, we want them to be unique equations. So for example, if I had put 6x plus 4y equals 10, notice that that's the exact same equation. I could just divide this whole thing by 2 and I would end up getting this. So that's why we end up getting the same equation as a result. Another thing that we want to be careful with is making sure we have the right set of equations. So going back, notice that I made sure that x was hamburgers and y was french fries. We can't have in this equation x being hamburgers, y being french fries, and then in this equation either flipping them or making this some cost or something else random. We need to make sure the units are preserved within the different variables, so that way we're talking about the same thing with the end product. So that's going to be a general look at how we solve these kinds of problems. Again, they're used in nutrition, financial analysis, any investments, pricing, a lot of financial stuff. Really anything you can apply these to. So they're incredibly useful to understand. So watch this video once more to get a better idea of it. We'll go over one more kind of random example at the top of my head. So let's say you have one type of car. Let's talk about cars. So you have one model of car that costs $30,000, and then you have another model of car that costs $60,000. Combined, a salesman ended up selling $1 million worth of cars, so we'll say. Well, then we know that he sold. A lot of times these word problems will tell you, oh, he sold, 100 cars, for example. I don't know if this is going to end up working out, but let's just go with it. So he sold 100 cars. Well, that tells us that x plus y, we don't know how many there are of each, but we know together they equal 100. Well, thankfully, we've created a system in which we have two equations and two unknowns. Now, I can tell you right now, this is not a realistic system. And the reason why is because the intersection, if we look on a graph, Or another way we could do it is solving it algebraically. We see the system shows that 166.667 cars of the one car was sold and a negative amount of the other car was sold. Obviously, that's not possible. You wouldn't come up with a situation like that in your book, but this would be the general way in which you find it. I personally believe that using the graphical method is the simplest, and it's by no means cheating. It's using the tools at your disposal to be able to find where these intersect, and it's a quick way to find your answer. However, if you're being asked not to use a graph, then you just solve it algebraically by setting these equal to 0 and then setting them equal to each other.